what we want to do, and we do that about once a year, is to give you a sense of what we do, where we go, how we change, and what remains the same. And if you think about it, for the past 12 years, we've done really one thing, and we had one promise. So the one thing that we delivered is the lowest latency for 1 bit. Wherever we could, that was the focus. And really nothing else was the focus. And the promise we had is equal treatment for everybody. And that's hard. That's hard because there are deals that you can't do, but it's something that we lived by, and that's not going to change. So none of those two things are going to change, but this year was very different. This year was very different because we launched services that are not the lowest latency and that require reliability. So we first launched a service with Euronext where we commit not to lose one single packet. And it's a remote order entry from London to Bergamo. And the target audience for that is probably none of you guys. It's more banks, it's broker-dealers, it's people who execute from London with their smart order routers. So that's the new audience. And it's a very new endeavor for us because we were always like, okay, reboot the thing during the day, who cares? We want to be first most of the day. And if we lose something, it doesn't matter. Now we have to retrain all the team so that they don't do that for one particular class of service. And then we recently launched another one, which is in the same category, which is time sync as a service. So it's a uniform time in New Jersey and a uniform time in Illinois. And that is sub-nanosecond White Rabbit. But the difficulty was really not just learning how to use White Rabbit in one place. It's about architecting the full thing so that it would never fail. So we can never say never. New Jersey could go out of power and we would fail, but it would fail in really extreme circumstances where we believe the markets would fail themselves, and not failing would not be very relevant. So that's another thing where we had to focus on reliability, which really is not our strong suit. We hope we've done a good job at it. And the last thing that we've done this year, and it's really not completely commercially available yet, but it's the raw market data offering, the historical market data offering, including a lot of raw market data, and which will at some point benefit from the time sync. It's not yet on our time sync, it's on our good time but not perfect time today. And the goal for all these things is to serve a new type of trading, not a new type of clients, you've been doing that, but it's to serve more machine learning type trading where the race is not last 10 nanosecond, the race is more big models within 10 microsecond. And for that you need a lot of data. So we've also focused on increasing the full raw feeds that we do. We've introduced a full raw feed from the CME delivered in New Jersey, which we go CME to Cermak with LMDS, then Cermak to New Jersey with the best spread network. And the goal there is to enable clients to have the fastest possible raw feed in New Jersey so that you can run whatever complicated model you have. We expect to focus on that a lot more. We expect to actually build a lot more bandwidth everywhere so that we can do that maybe in Europe, raw feeds from the different places, Frankfurt to London, and do that in many places where we really do something different. Before we used to try and understand what you use. So we do signals. And for that, we need to understand what you need. And for raw feed, we don't really need to understand exactly what you need. We just need to provide everything. And that's a bit of a change of philosophy for us. And it's also something that opens up probably many more clients. So we're going to look at to serve a wider array of clients in the future. Anyway, so we haven't changed and we have changed. That's the message. And I really said everything that's on here. You know, lowest latency, we're the best, and where nobody controls us. So as we expand with more data offerings and more services, we decided to try and simplify a little bit our alphabet soup. So we are going to, and that's going to take some time, but we're going to move away from QRD, QPD, QED, QFD, QHF, and more like a more descriptive version of what we do. So we'll have raw feeds, snapshots, and signals, and different ways of delivering them. So this is just a preview of the fact that we'll talk in a different way, hopefully in a way that is more legible for everyone. And if you think of it, let me, go to an example of that. So from the CME, which is still the center of the world, and the day that crypto becomes the biggest trade, then maybe CC2 is going to be the center of the world, but for some time CME is still the center of the world. So from the CME, we have snapshots going to Asia, raw data going to ICE, and a lot of things going to New Jersey and things going to Europe. And I will discuss in this talk the raw data to ICE and the signals to Europe. I really should pause and say, please interrupt and ask questions at any time. I'll feel bad if nobody asks a question. Time for question? You want to make me feel bad for a little bit? Oh, thank you.
Will we get a copy of these slides?
I can dedicate a copy to you. I can sign one up.
I don't want to have to take too many notes.
No, absolutely. And John, really what we are doing, do you remember we had exchanges at some time in the past and they were interesting and at some point you said, but you guys, you're on to a market data business of $2 billion a year. We're not there yet. But to get there, we need to broaden our offering. And maybe we'll do what you thought we should do 10 years ago. Maybe we'll get there. I hope we get there. Anyway, so thank you.
One more quick question. How did you decide what not to talk about? You picked two things of your list. Why not the rest?
So I thought it would be good to make sure that we would still focus on the first bit trading things. And that's what we've been doing for 12 years. We do new things, but we assume that you're still more interested in our main focus, which is the first bit one. So that was the choice. So okay, CME to ICE, raw data. We say fastest. It's only because it's our own fastest offering, but it's not the fastest. And I'll get into that. And that thing is what we're trying to fix. So let's look at that. So the problem is you go from the CME on the left, you receive data at 10 gigabits per second, you have a pipe, and our pipe has a varying bandwidth, but let's take for the example 5 gigabits per second, and you want to send it to the other side at ICE. And if you receive a 1,000 byte packet from the CME, and somewhere 300 bytes in, there's a trade summary message that's really important to everyone, then you need to focus on the transmission time of that sliver of information, which is in red over there. So how do we do it today? So today it goes to the radio, it goes, just straight through to the wireless, arrives on the other side, and there starts the problem. You kind of do that little store and forward. And, why do we do store and forward? Why do we do store and forward? Someone has to tell me.
Speed conversion.
Speed conversion. So that's like if you receive at 5 and you unpile at 10, you'll have bubbles in the air, in between, and that's not easy. And there's also a little bit of another reason, which is you get your checksum at the end of the packet.
UIP fragmentation.
So we can do some kind of fragmentation. That's exactly what we're. So, okay, anyway, so today that's what we do, and the client gets the information when that red sliver reaches on the other side. But, as you pointed out, there's another way of doing it. And the other way of doing it is actually, as you serialize on the lower end, you will introduce a little bit of idle words in a big jumbo frame so that you can adjust the speeds. And if you do that, then instead of doing store and forward at the beginning, you actually serialize very quickly, and you end up with something where the nose of one of the packet is aligned with the queue of the other packet. And then, of course, when it reaches the client, one comes in first, and the other one comes in after. So we're going to introduce that, and it's called SFI for Streaming Frame Interface. It won't be called SFI, it will be called Streaming Frame Interface, so that it's legible. And the question is, how much do you improve the latency by? And of course, we'll have two handoffs. So whoever wants to keep the one or have both, I expect most clients interested in first bit trading to take both. So to understand how much you gain in latency, you need to run the number of the raw data, and you need to make some assumption as to what is the bandwidth that you're running at today. And the bandwidth you're running at depends on propagation conditions and various things. So we have different bandwidths. We're never as low as 1, but 1 is an easy thing to compare with. So if you look at the yellow and the blue, you have the latency for the trade summary message going either store and forward or streaming frame interface. And what's really interesting is the difference between the two curves. And likewise, you have the difference between the red and the green, which is a thing of interest at 6.4 gigabits per second, which is something that is a usual bandwidth for us. And you'll get the slide, so you can read the legend and how we did the calculation and everything. But if I focus on the difference, I will focus here on the difference only for the case of 6.4 gigabits per second. And what you read here on the horizontal axis is latency in nanoseconds, and it's latency savings if you want to receive your trade summary message with the streaming frame interface. And we've dissected that into big trades, smaller trades, yet smaller trades, and tiny trades. And you can see that for the big trades, which we've defined as size of 11 or more on that particular day, the gain, and I really shouldn't have a pointer, but if you look at 1.5 microsecond, 1500 nanosecond, you go up, and it's under 10% the intercept, which means that more than 90% of the time, your improvement is better than 1.5 microsecond for the big trades. So that's a huge change. And it's a change which is a little bit like the change that we brought to the market with QFD, sorry for the acronym, which is signals from the CME to New Jersey. And if you think about it, what we actually brought to the market is, good latency, but also good latency for everybody. Because when you can deliver the best latency through market data, you can deliver it to everybody. And that QFD, the signals to New Jersey, changed the market in New Jersey quite a bit. Like, we heard of firms that benefited from it, we heard of firms that hurt from it, and but it took time, but it really reshaped a little corner of trading. Not trading in general, but a little corner of trading in New Jersey. And it probably deflated the value of competing lines for first bit trading. Of course, competing lines can be used for many things, but for first bit trading, it did devalue the value of competing lines. And we think it's going to be the same here between CME and ICE. And the goal is to roll this out in New Jersey and to continue and probably roll this out in other places.
CME and ICE is Illinois, no?
Yes, so that's the first target. And the goal is to then roll out the same idea in New Jersey. No reason, I don't know that the gain is as big, but there'll be a gain. And the goal is to offer the best and fastest signals as well as market data to everybody.
Just to be clear, the sizes here, this is like your chunk size that you're sending like in between. So you buffer for 1 byte or whatever, and then you send out 1 byte as a frame. Or versus like 1 to 3 bytes, which is 3 to 11 bytes. That's what the size means there.
No, those things here is the latency gain, not from how we stream. We stream always, the assumption is we stream the same way. The latency gain is, what is the latency gain for small trades and big trades? And the latency gain is bigger for big trades. And you would expect that because it's bigger packets, and maybe the trade summary is like deeper in the packet, and so that's what you see here. Maybe I should pause for a question because I'm going to go on the next one. Or maybe I should pause for advice. Where should we roll this out? What's the next sweet spot, like sweet target? NASDAQ FPGA, Eurex, like what do you want? And you're not competing, like you're friends tonight, Tonight you're friends, like don't worry. All right.
Here an hour of cocktails before the meeting.
Okay. All right, we'll have one-to-ones. As NASDAQ said, they want the feedback in one-to-ones. It's more fun in public, frankly. So let me go then on to the second topic. And the second topic is the shortwave signals. And we've wanted to do shortwave forever. Like we tried to develop something forever. And we've studied shortwave forever. So we had a first iteration of our system, and we had ideas of signals that were really smart, and everybody told us they were really stupid, and and we should really just send the trades. So we heard that, and we are just sending trades. What we wanted to do is we thought we would be up last June, and we were actually functional in March. It looked good in March, and then it broke down. And like, we don't know, like HF is really hard. So I'm really not trying to promise that we'll be great all the time, because we haven't been through a yearly cycle, and I hear the real cycles are like 20 years. So it's going to take a long time before we get there. But, if we've done studies on HF for a long time. And the studies are essentially the lead lag. So you look at CME, you look at big trades on ES, and you try to find echoes on DAX. And that's our way of looking at it, and we've done that forever. And what is striking in this picture is that the way the number of HF-mediated signals has grown over the years a lot. If you look at the pinkish line, that's the oldest one. That's the heyday of Hibernia. Like, most of the transmission was over Hibernia. If you look at today, most of the transmission is on the HF side. And that what you're looking at here is echo count in Frankfurt as a function of latency, of transmission latency, time elapsed after a big move on ES. So if you take this graph and you put a dividing line in the middle between the two peaks, you can see what percentage is to the left and what percentage is to the right. And you can plot those percentages as a function of time. So that's what it is. And it's really the percentage of time the shortwave beats transatlantic fiber. And you can see 2019, it was semi-early days, 35% of the time. It was good, but not great. And there was rapid improvements. And in 22, it reached 70%. And it hasn't really moved since then. So it's about 70% in what we see. What has changed in our studies? Yes, please.
When you say transatlantic fiber, is that the confluence of microwave to the East Coast plus transatlantic fiber?
So the pinkish line here is microwave CME to New Jersey, NY5, I believe, and then NY5 to LD4, Hibernia, and then microwave LD4 to Frankfurt. And that's exactly the latencies that you can back out from whoever provides those services. So you can see that there's a bit of a plateau here. But what's fun for us is now we're in a position to actually see what we would do in our offering. So we do the same study here, and here you can see the color is not great. It's blue and blue. But the darker blue is the trade count that we see in the market data, and the lighter blue is the Quincy service, is the signal service. So from this you can see, yeah, we're kind of in the right ballpark. But as you can see, we can attribute every signal to an echo. So we can do a one-to-one comparison. And what's more interesting than this graph is to go one-to-one for every signal that we receive in Frankfurt. You can find the echo, and you can do the distribution of the difference in latency between those two things. So that's what we do here. And if it's positive, we win. And if it's negative, we lose. So you can see that on the echo that we find, we win like a good fraction of the time. And the different colors are the different signal strengths for ES. So big ES, medium ES, move. And you can see that this, at least on the small sample we have, it doesn't look like there's a strong correlation between color and the fact that we win or we lose. So it's not, like you're always afraid of losing on the big ones and winning on the small ones. It does not seem to be the case. And when we win, it looks like we win fair and square. And when we lose, we have excuses, you know. That's a good thing. Maybe it was a private fail, you know. Maybe it's something different. So maybe we lose in cases where we could never have won anyway. And maybe we win an even bigger fraction of what we can win. So, so this looks so far reasonably good. We're hoping, and that opens up obviously a lot of work for us, because if it works there, it should work to other destinations. And the number of HF systems that have been built all over the world seems quite high, so we have a lot of catch up to do. Let me pause for questions here, because after that, we really have only the mugshots.
If the number of HF stations around the world is quite high and you feel like there's catching up to do, is your intent to sort of chase the same things or offer sort of complementary service offerings as well?
Would you repeat?
I'll repeat the question. So,
No, I meant Stephane.
yeah. So as we think of going to other places in the world, are we trying to do complementary offerings, or are we trying to do the same thing, chase the same things? So it's a really interesting question. And if you think just from CME to Europe, our initial hope was to be okay CME to Europe and then win to Mumbai because we have an edge to Mumbai. As you seem to be good, like you change your goals. So if we're good enough, we'll try to beat on the most important signals, to beat at, you know, whoever's competing with us. If we're not good enough, we'll try and use it for something different. You know, it's really a question of how we feel we stack up. And it's easy to study CME to Eurex. It's not that easy to study CME to Mumbai or, you know, CME to Shanghai. Now, that's really hard. So for the rest of the world, I think we'll rely on a little bit of feedback. And usually the feedback, as soon as you're kind of credible that you can do something, you do get feedback from the guys who lose. You know, the guys who win, like, they don't tell you anything. The guys who lose, well, they'd like you to get a crack at it. So we'll probably get some feedback. It's hard for everyone to win.
Going back to the win rate of HF versus transatlantic fiber, was that more of a function on your end, testing empirically, given the receiver missing a signal and having it traverse the globe again before being received, or fully losing the actual payload and requiring or allowing fiber to be without range retransmission?
So this graph here is not us. This graph here is only what we see in the market data. So what we believe is that it's the times when the HF propagation's not good enough and nobody's receiving this. And you have to think that there are many different systems competing. So like the most robust of the systems that are in competition today doesn't make it.
When you're measuring Quincy signal winning, is that overall like in on the basis of the like that original histogram that you were showing, or is that based only when you guys receive and like actually decode your actual signal? So like with HF, you have some percentage of time you're not going to be able to receive and decode it. So you're measuring only the times when you're actually doing well, or is it against the entirety of the signature time?
It's only the things that we receive. So, like, we're not in a position yet to tell you how many times we receive in total, but when we do, we seem to do well. And it's early days for us, frankly. So thank you very much. Thanks very much for being here. And I hope to see you soon in a one-to-one setting.